In this lecture video, I want to show you how to use StatCrunch to perform a two-way ANOVA, particularly with your homework. In this example, we are given pulse rates, and the two factors are age group and gender. When you're working on your homework, you have the option to open up the data set and view it in StatCrunch. Here I have all of the data values for this example entered into StatCrunch for us. In order to run the two-way ANOVA, we first go to Stat, then ANOVA, and select two-way. We need to choose where the responses are, the row factor, and the column factor. Typically, these are labeled pretty clearly in our homework problems, but every now and again they can get a little bit interesting. Responses are the values that are in the body of the table. The row factor is the factor that's listed and labels each row, and the column factor is the other factor that labels all the different columns. Now we'll simply press compute. This runs the two-way analysis of variance for us and gives us all of the data output that we need. We have all of our test statistics and all of our p-values. So let's take these to the example. The first step in this process is to run a test for interaction. If the two factors interact, it will not be appropriate to proceed with testing for row and column effect. So this is an important first step. With this test, the null hypothesis is that there is no interaction between age and gender. And the alternative hypothesis is that there is an interaction. Looking at the values that we got from StatCrunch, we look in the row titled Interaction. We find that our test statistic, F, is equal to 0.939, and the p-value is equal to 0.3973. That's a large p-value, significantly larger than our level of significance, alpha, which was 0.05. This means that we fail to reject the null and conclude that there is no interaction. We can say that there is no interaction between age and gender, which means that we can proceed with this process. The second step is to test for row and column effect. Let's call it step 2A and test for row effect. With this test, the null hypothesis is that there are no effects from the row factor. Our row factor is age, so the null hypothesis is that there are no effects from age, which means the alternative hypothesis, H1, is that there are effects from age. In other words, the null hypothesis is the idea that age does not affect pulse rates, but the alternative hypothesis is that age does affect pulse rates. From StatCrunch, we'll look at the row titled Row Factor. We find our test statistic, F, equal to 1.816, and our p-value equal to 0.1725. We again have a large p-value, greater than our level of significance, alpha, which is 0.05. So for this test, we also fail to reject the null. And we conclude that there are no effects from age. In other words, age does not appear to affect pulse rates. Finally, we test for column effect. With this test, the null hypothesis, H0, is that there are no effects from the column factor. Our column factor is gender. So this null hypothesis is that there are no effects from gender. This means that the alternative is that there are effects from gender. From our StatCrunch output values, we want to look at the row titled Column Factor. We find our test statistic, F, equal to 13.591, and our p-value equal to 0.0005. This is a small p-value. It's less than our level of significance, 0.05. So for this test, we reject the null. We conclude that there is an effect from gender. In other words, gender does appear to affect pulse rates. This is the entire process of a two-way ANOVA. We started with our test for interaction. Since we found that there was no interaction, we proceeded to test for row effect and column effect. We tested to see if pulse rate was affected by age, and then we tested to see if pulse rate was affected by gender. Back in step 1, if we had found that there was an interaction between age and gender, we would have stopped right there. It would no longer be appropriate to finish the rest of this process.